Hello, everybody. This is Dr. Nurbat Shah. This is a new series of lecture recordings or lecture videos for solution of differential equations. So this lecture is about how do we solve if the differential equation is separable. In this lecture, I'll be talking about what do you mean by separable equations and how would you know whether a differential equation is separable or not. Our main focus in this lecture will be on ODEs, that is ordinary differential equations. Okay, so what is a separable equation? If any differential equation, ordinary differential equation, which could be expressed in the form of dy by dx, that is equal to g of x and h of y. Like in this case, you see, you can express the given differential equation dy by dx, that is the product of two functions. One is completely a function of x, whereas the second one is a function of y. Some of the examples are, you see, dy by dx, that is equal to x square y e power x plus y. Now, this equation can be written in the form x square as it is. This is e power x, and then we have y, and then we have e power y. Now, these can be rearranged in a way that we have c x square e power x and y e power y are separated. So this is our g of x, whereas the other one will be h of y. So g is completely depending on x, whereas h will be completely depending on y. Whereas the second differential equation, if you see dy by dx, that is equal to x plus y, this cannot be written in the form f multiplied by g, where f is a function of x and g is a function of y. So we cannot express this equation in this form. So this one is not separable equation. Okay, so how do we solve this type of differential equation then? So you know that if a function is already expressed in the form dy by dx, that is equal to f of x and h of something y. So we simply separate that. We will be writing dy by hy, and the right side will be dx, will be multiplied with f of x. So we'll be having f of x into d of x. And then the next is what? Solution of a differential equation basically means to integrate the equation. So we need to integrate this form. Okay, so this will be integrated if you know the integral of this one or antiderivative of this one. Same thing will be here, and then that will give you a solution of the differential equation. Okay, so we need to solve this initial value problem. Cos x e power 2y minus y dy by dx is equal to e power y into sine 2x, with the initial condition that y of 0 is equal to 0, which basically means the value of x that will be 0 when y will be 0 when x is 0. Okay, so first we check whether this equation is separable or not, and obviously it is separable because you see, if we take this cos x to the right side here and this one to the right side as well, so this will become what? This will be divided by e power 2y minus y, and similarly this will be divided by cos x. Now you see that this function is what? This has been expressed as a product of two functions. This is completely a function of x, where this will be completely a function of y. So it means this is a separable equation. So we do not write that this equation in this form. We simply separate them. We take everything which is depending on y towards dy, and anything which is depending on x will be taken towards dx. ओके सो इस इक्वेशन को हम इस फॉर्म में लिख सकते हैं. अगर आप देख लें तो इस पार्ट को जो e पावर y है, दैट हैज बीन टेकन टू द लेफ्ट साइड, वेयर एज दिस पार्ट is this one cos x is taken to the right side. So we could write this in this form, that is e power 2y minus y divided by e power y dy, that is equal to sin 2x divided by cos x dx. अब आप देख सकते हैं कि यहाँ पर कोई x मौजूद नहीं है और यहाँ पे कोई y मौजूद नहीं है, तो इसका मतलब है कि ये सेपरेबल इक्वेशन था और ये हमने सेपरेट कर दिया है। अच्छा, अब इस इक्वेशन को हम इस फॉर्म में भी लिख सकते हैं। अगर आप देख लें तो e पावर 2y के नीचे भी आ जाएगा e पावर y, एंड सिमिलरली y के नीचे भी आ जाएगा e पावर y। इसको डिवाइड कर देंगे, सो यहाँ पर एक 2y कैंसिल हो जाता है इसमें से एक, because powers will be subtracted, so 2y minus y, so you'll be getting what, यहाँ पे हमारे पास आ जाएगा e पावर y, ठीक है, और ये आ जाएगा y e पावर माइनस y। whereas यहाँ पे अगर आप देख लें तो we have a trigonometric identity sin 2x is equal to 2 sin x into cos x, and that obviously will cancel this cos x and cos x to get this 2 sin x, right? Now it's simple to integrate, right? Integration on both sides will be getting what? It's e power y minus y e power minus y integral of 2 sin x dx. Everybody knows that integration of e power y is e power y, whereas this integration will be found by using integration by parts, which can be done easily. See that y e power minus y dy, this can be found as you see if you're keeping this one fixed and integration of this one, we call this one the first function, and this one will be taken as second function to apply integration by parts. So how do we do that? Keeping e power y, y fixed, and integral of e power y minus y will be minus e power minus y. Okay, so just that's e power minus y, and then we have minus, then integral derivative of y will be 1, whereas integral of e power minus y, that will be again minus e power minus y. Okay, and if you integrate that again, it will become what, minus into minus plus, and then again we get minus. So and this minus of the formula as well, so all together we'll be having e power y plus 1, because you can simply take common e power minus y. The next step will be to simplify this, it is minus e power minus y into y, and this become minus e power minus y. You see that if you take this e power minus y common, so we'll be getting simply y plus 1 into e power minus y. And you know integral of sine x, that is minus cos x. Plus c is obviously important because you know it's a constant of integration. Now applying this initial condition, putting x equal to 0, y is equal to 0 in this equation, we will be putting y equal to 0, so giving you 1, y equal to 0, it will be giving 1, y equal to 0, that will be 1 as well. So we have 1 plus 1, whereas cos 0 is also equal to 1, so we'll be taking minus 2 here, and then plus c, which will be giving you c is equal to 4. So this arbitrary constant will take value c is equal to 4. ठीक है, अब ये वैल्यू हम क्या कर देते हैं, इधर हम पुट करेंगे जनरल सोल्यूशन में टू गेट द वैल्यू ऑफ this equation, or to get solution of particular solution of this equation. So we have e power y plus 1 e power minus y minus 2 cos x plus 4, that will be solution of this differential equation. अच्छा, अब बाज़ औक़ात हमारे पास इक्वेशन ऐसे होते हैं जो कि डायरेक्टली सेपरेबल तो नहीं होते, लेकिन वी कैन मेक देम सेपरेबल बाय डूइंग सम सब्स्टिट्यूशन। अब वो सब्स्टिट्यूशन क्या होगी, ये तो आप गेस कर सकते हैं कि बाय यूजिंग विच टाइप ऑफ सब्स्टिट्यूशन आई कैन मेक दिस इक्वेशन इज सेपरेबल। और सेकेंडली फिर ये है कि आप कुछ रूल्स हैं, कुछ टेक्निक्स हैं जिनको आपने फॉलो करना होता है। द फर्स्ट वन इज इफ an equation is not separable, but the right side, the function in the equation, you have to write differential equation in this form first. Y dash is equal to f of y by x. Maybe you can write that y dash is equal to g of x by y. Okay, तो अगर कोई भी इक्वेशन हम इस फॉर्म में एक्सप्रेस कर सकें उसके राइट हैंड साइड को, तो वो हम कहते हैं कि दिस इक्वेशन विल बिकम होमोजेनियस. ओके, एंड होमोजेनियस ऑफ सर्टेन डिग्री 0. तो इसके बाद फिर क्या करते हैं, we make this substitution. We take y is equal to ux. Basically, we are replacing, or we are changing the variable from y to u, right? Or you can take x equal to uy as well. राइट, इस केस में क्या हो जाएगा, ये जो इक्वेशन होगी, दिस इक्वेशन विल बिकम separable in u and x instead of y and x. It will not be separable in case of y and x. Okay? And when y is equal to u or u multiplied by x, so y dash will be taken as u plus x du by dx. Okay, because you see multiply using product rule, u को fix करो, ठीक है, और x की derivative that will be 1. Sorry, go back. The derivative of u will be u will be kept fixed, derivative of x is 1, and the next step is x is kept fixed and derivative of u will be du by dx. So we'll be replacing all these things in the given equation, and that equation will become what? Separable now in x and u. I'm explaining by example. Okay, and if you have a function of like that, if a function of the form y dash is equal to f of ax plus by plus c, this is obviously not separable. But in this case, we make a substitution that is ax plus by plus c will be taken as u, and then obviously when you replace y with u, so we need to replace y dash with u dash as well, which can be simply found from by differentiating this function u dash, that will be a because x derivative will be 1, b y dash, and c derivative will be 0, and then solving it for y dash. So y dash will be replaced with u dash minus a divided by b. Okay, so if you want to solve this differential equation, it's 2xy y dash is equal to y square minus x square. And if we divide this equation by 2xy, that will give us y by 2x minus x by 2y. So you see, this is what this is it not expressed? The complete right hand side is y by x or x by y. The answer is yes. Or you can say this equation is homogeneous. The given differential equation was homogeneous, so that could be expressed in this form. Now we make the substitution as I explained earlier. Y dash will be replaced as u plus x u dash. We have called y by x as u, so this will be replaced with what? With the u, and 2 is there. Whereas this is x by y, so it will be replaced with 1 over 2u, which could be simplified. You just take u to the right side, okay, and then simplify to get this equation. So we have now x u dash is equal to this one, and now this equation is separable, which could be separated in this form. So we have 2u by 1 plus u square du, which is equal to minus dx by x, and then integrating both sides, because इधर आप देखें ये separable हो गया है, इस साइड पे complete function of u है, जबकि इस साइड पे हमारे पास क्या आ रहा है, function of x आ रहा है. Now this could be integrated. You see 1 plus u square has a derivative in the numerator, which is 2u. So there is a rule in antiderivatives: if a function has a derivative in the numerator and the function in the denominator, then its integral is simply log of this one, log of the denominator. And similarly, minus dx by x, that is minus log of x plus log of c you can take, and then we can simply simplify this one to this form, right? You can simply replacing u by what, that will be replaced now by y by x, so it's have log of 1 plus u squared, that is 1 divided by y squared by x squared, and so on. Okay, so this final solution would be x squared plus y squared is equal to cx. That's the solution of this differential equation, which might be written in this form because just want to explain this is representing a family of circles, right? Okay, let me just do some practice questions for you. Y triple dash, sorry, y cube into y dash plus x cube is equal to 0. Now, first we check whether this equation is separable or not. The answer is yes. If we take this equation to the right side, x cube and y cube will be left on the left side. So then dividing both sides by y cube, so we will be getting dy by dx is equal to minus x cube into 1 over y cube. So yes, that's separable. So we don't need to check that again and again. You can see from here, if you could take everything a function of y with dy and a function of x with dx, so we say it's separable. So we can do that in this form. So you see y cube dy is equal to minus x cube dx multiplying by 4. ये इतना जरूरी step नहीं है, लेकिन you know that कि y cube का जो इंटीग्रल होगा वो y 4/4 हो जाएगा, तो just to get rid from 4 at the beginning, we are basically multiplying on both sides, तो ये फर्क नहीं पड़ेगा, 4 फिर भी कैंसिल हो जाएगा. So we have 4y cubed dy minus 4x cubed dx. Integration on both sides will give you what? That will give you integral of 4y cubed dy, that is y power 4 by 4, whereas minus 4x cubed dx, that will give you x power 4, right? And then plus c, some arbitrary constant, which might be written in this form: x power 4 plus y power 4 is equal to c, but that is the implicit solution of this differential equation. Okay, if you want to solve this, y dash is equal to secant square y. Okay, so y dash is equal to secant square y, again separable hai. Yes. Can we write this in this form? The answer is yes. We simply divide the secant square to the left side and dx to right. So we have dy by secant square y is equal to dx. जहां से हमारे पास ये आइडिया आ जाएगा था कि 1 by secant square जो है that is equal to cos square y. So cos square y dy is equal to dx. And the next step will be simply finding what? Finding the integration on both sides. Okay, so if we find integration on both sides, cos square cannot be integrated directly. So using again trigonometric identity, we know that cos square is equal to 1 plus cos 2 divided by 2. So we have 1 plus cos 2y by 2. If it was sine square y, so we'll be taking 1 minus cos 2y by 2. Whereas x could be integrated as simply x and plus some arbitrary constant. Now this could be integrated easily. Integral of 1 is y, whereas integral of cos 2y will be now sine 2y divided by derivative of 2y, which is 2. So it will give you sine 2y divided by 2. You see, 1 by 2 is this one, and then we have y plus sine 2y divided by 2 is equal to x plus c, is the solution, implicit solution of this differential equation. Let's do some more questions. Y dash sine 2 pi x is equal to uh, pi y into cos 2 pi x. Again, we see whether it's separable or not. So the answer is yes, it is separable. We can simply divide this y to the left side. So we can have dy divided by y equals pi. And then we have cos 2 pi x divided by sine 2 pi x into dx. Okay, and the next step is what? We have to integrate this on both sides. So now dy by y, that will give you integral log of y equals, where you see again this function has a derivative in the numerator. Derivative of sine 2 pi x is cos 2 pi x into 2 pi. So it means यहाँ पे 2 pi तो है लेकिन 2 missing है. So what can we do? It can be simply written as 1 by 2. You may write 2 here, that's also okay. So this will be here 2 here, let's cancel this one and multiply by 2 here. So this will become simply 2 times log of y, and this will become what? Sine 2 pi x as a derivative 2 pi into cos 2 pi x in numerator. So that would simply give you log of the denominator, which is sine 2 pi x. Plus, whenever we have log in every term, from integration, we should take log with the constant as well. So it will be log of c. So we could write this in the form log of y square can be written as log of c sine 2 pi x. Or we just apply exponential to get solution like y square is equal to c sine 2 pi x. That's the solution of this differential equation. Or you may take square root on both sides to get a particular solution. Okay, and to get a solution, okay, explicit solution. Sorry. Okay, I hope it's clear to everybody. If you have any question, you simply drop a message in the comments box, and I'll get back to you. Okay. Also, subscribe the channel to get notification when new videos uploaded. Okay, the next question is y dash plus 36x is equal to 0, which can be simply solved again. Okay, you see It's separable because we could write this equation in the form y dash that is equal to minus 36x, or this could be written y dy that is equal to minus 36x dx. You see that it is already separable. Okay, and again, just for sake of simplicity, we may write this as 2y, and 2 here is, well, sorry, it's 2 multiplied by 36. Integration will give you what? That will give you y square that is equal to minus 36x square plus some constant c. Or we can simply say 36x square plus y square that is equal to c is the solution of this differential equation. Keeping in mind this 2x is given integral is if it's not clear to you, basically मतलब मेरा ये है कि 36 पहले से मौजूद है और यहाँ पे आ जाएगा हमारे पास 2x. तो जब मैं इसको इंटीग्रेट करूंगा 2x को, so I'll be getting x squared directly, and 36 as it is आ जाएगा. So this is basically a class of ellipses, which is the solution of this differential equation. Okay, so let's move to the next one, and that's a practice question. You can do that. Again, you see this is a separable. It can be written as dy by dx. So see dy. Sorry. Okay. All right. So it's dy by dx would be written as 2x minus 1 in the power of e and y square. So this can be again separated easily. So dy by y square is equal to e power 2x minus 1 into dx. Okay, integration on both sides. Integral of 1 over y square, that is minus 1 over y, and that is equal to e power 2x minus 1 divided by 2. And then we have plus some constant c. Okay, it can be simplified as well if you want to have an explicit solution. So this could be written in this form as, you see, multiplying minus over there and then just take the reciprocal of it. Okay, so the next question is xy dash that is equal to y. Now you see this equation is not separable, but if we divide this by x throughout, so we would write that as y by x plus 2x square into sine square y by x. What did we do? We have divided the given equation by what? By x, right? And then we put this, make the substitution y by x is equal to u, or we say y is equal to ux, which leads to y dash that is equal to x u dash plus u. Now putting this value in the given equation to get this equation like that, x u dash plus u is equal to, you just replace this with u as well. So we have u plus 2x square into sine square u. You can cancel these two together, and then we may cancel one x as well. See, so equation becomes what? U dash or du by dx, that is equal to, we have this 2x into sine square u, which could be separated as well. So that could be written in the form du by sine square u is equal to 2x dx. And after integrating the given function, we'll be getting what? We'll be getting, this is cosecant square. So its integral will be minus cotangent u, which is equal to x square plus c. Right, and then we replace this one with, or we can say cotangent u that is equal to cotangent y by x, sorry, that is equal to, it's cotangent y by x, which is minus x square plus some c, another c which is obviously equal to what? Minus c. We may have an explicit representation for this as well, and that would be written in the form as y by x is equal to cotangent inverse minus x square plus c, right? And you can simply multiply x over there then. Okay, the next equation is y dash is equal to y plus 4x whole square. Again, this equation is not separable, but we can make it separable by using the rule as I explained earlier. If we have something ax plus by plus c power function something, in this case the function is square. So we make the substitution by taking this one as u or whatever. So let's suppose we take this as v, that is y plus 4x, and then v dash will be it's y dash plus 4, or we can say y dash is equal to v dash minus 4. Now putting this value in the given equation here, so we have v dash minus 4 is equal to v squared, or we may write that as v dash, which is dv by dx, is equal to 1 divided by 4 plus v squared. Now this is separable. Sorry, it's not 1 divided by, it's simply 4 plus v squared. Okay, so this is separable now because we could write this in the form dv divided by 4 plus v squared is equal to dx, and integration on both sides leads you towards integral dv by 4 plus v squared is equal to integral dx. This is what? This is tangent inverse v by 2 and then 1 by 2 is equal to x plus some constant c, which will be then replaced by what? We can have tangent. Okay, we have tangent inverse. Okay, and this will be x plus y plus 4x, and then this is divided by 2 is equal to, again you can simply multiply by 2x, so we get 2x plus some other constant, let's suppose a, where we can simply take this to the right side multiplying by 2, and then you will be getting the expression for y. So let me try if I could write it here. This implies y is equal to, right, so we have minus 4x plus 2 times tangent 2x plus a. That required explicit solution. Okay, right. I hope it's clear to everybody now. Let's move to the next question. It's a very simple one. X y dash, that is equal to y cube plus y. So this is separable, right? So simply you would divide y cube plus y to the right side. It's y square presumably. Whatever, it's good to be anything. And then using partial fraction to find the solution of this equation. I hope you could do that. Okay, the next one is xy dash, that is equal to x plus y. So dividing both sides by x first, so we have y dash that is equal to x by x plus y by x. It means the right hand side has been expressed as a function of y by x, so it's homogeneous. Therefore, we could replace u as y by x, and y dash will be replaced as x plus xu dash plus u. And then putting this value here, so y dash is replaced as xu dash plus u, that is equal to 1 plus u. So we see u and u will be cancelled, and that would give you x to du by x into du by d, come on, x du by dx is equal to 1. This is x, not q. Okay, so इसको फिर हम separate कर सकते हैं. du is equal to 1 over x dx. And then integration will give you what? U is equal to log of x plus c. Whereas u was taken as y by x. So y by x is equal to log of x plus c. Or you can simply find the value of y. So y is equal to x into log of x plus c. Right? So that's the explicit solution for the given differential equation. Okay, now we are basically solving initial value problem here. So solution for this one will be somewhere here. Let's talk about solution there. So this can be separate as well. You see, we could write this equation as xy dash is equal to minus y, and we could write this one as dy by y is equal to minus dx by x. Right? Integration on both sides will give you what? Log of y, that is equal to minus log of x plus log of c, because we are having log everywhere. So this could be written in the form c log of y, that is equal to log of c by x, or y is equal to c by x. Now using condition x is equal to 4, y is equal to 6, that gives you what? C will be y is 6, x is 4, so c by 4, which gives you c is equal to 24. Okay, and then putting this value in this equation to get the final particular solution. Okay, so this is y is equal to c24 by x. That's the particular solution. Okay, similarly, I hope you will be able to do that as well. That's y dash is equal to 1 plus 4y square, and y of 1 is equal to 0. So in this case, obviously, it's directly separable. So it's dy by 1 plus 4y square, that is equal to dx. So integration on both sides would give you, इसको हम ऐसे लिख सकते हैं ना, 1 by 4 into dy by 4 plus 1 by 4 plus y square, just to make it easily integrable. So that is dx. So the left side will give you 1 by 8 into 10 inverse 10 inverse y by 1 by 2 is equal to x plus c. Don't forget about c. So, or we could write this in the form tangent inverse to y tangent inverse to y, it becomes 8 times x plus c. Okay, and then applying this condition by putting y is equal to 0, it will give you 0. Okay, and that will give you x is 1, so it is 8 into x. C, x is 1, so we're taking 1 plus c, which gives you c is equal to minus 1. So therefore, given solution becomes what? That is 10 inverse to y, that is equal to 8 into x minus 1. Or we can simplify that, taking 10 to the right side and getting y as a function of x. Okay, so same solution for this one. Again, it's a separation of variable, which can be done easily. I hope you will be able to do that. Just practice it. And if you have again any query about it, so you can just ask me then. It's a practice question for you at home. So, okay. So let me do this one for you. If y dash is equal to x plus y minus 2 square with a condition y of 0 is equal to 2. So this is again a non-separable. So we can reduce that to separable by introducing another variable v. You can take any variable that is x plus y minus 2, and then we have dv, which will be dv by dx or v dash. We can say that is 1 plus y dash. Okay, our y dash is equal to, that is dv by dx minus 1. So the equation becomes v dash minus 1 equals v squared, or we say that is v dash is equal to 1 plus v square, or we can say that separation of variables. So dv by 1 plus v square is equal to dx. And after integration, we get this is tangent inverse v, where this will become x plus c. Putting the value of v, so we can put that as tan inverse, whereas v will be x plus y minus 2 is equal to x plus c. By using condition y of 0 is equal to 2, so putting x equal to 0, y equal to 2, so c will be 0. Because c, this will become 2, this is 0, plus 2 minus 2, so that is 0. Tan inverse 0 will give you 0, and this is also 0, so c is equal to 0. So therefore, the general solution will, in this particular solution, will be tan inverse x plus y minus 2 is equal to only x, or you can say x plus y minus 2 is equal to tangent x. Okay, or you can simply simplify that in y is equal to tangent x minus 2. Okay, the same thing in question 14. That's the next practice question. Most of the questions are taken from the book of Krzyk, Advanced Engineering Mathematics by Erwin Krzyk. So these are the questions from there. So again, this equation is not separable, but we can make it separable by dividing it first by x. So this equation becomes y dash is equal to y by x plus 3x cubed, it's cos square y by x. Right, now you see that everything is expressed on the right side as a y by x, so it's replacing this with, by making substitution, that u is equal to y by x, and u dash, y dash will be replaced as x u dash plus u. So this equation will become what? Y dash is replaced as x u dash plus u. This is u. This is 3x cubed into cos square u. We may cancel these together to get x, and then again you can cancel this x as well. So we have x squared here. So we have du by dx is equal to, it's cancelled, so we have 3x squared into cos square u, which could be separated as du by cos square u is equal to 3x squared into dx. This is integral 1 by cos square. Everybody know that it's the secant square u, secant, okay, secant square u du, that is equal to integral 3x square dx. So that will give you integral of secant square u, that is tangent u is equal to x cube plus c. Or we can write tangent, again y by x is equal to x cube plus c. Now again, applying condition with x is equal to 1 and y is equal to 0, mean to say this will become 0. 10, 0 is 0. So 0 is equal to 1 cube plus c, which give you c is equal to minus 1. So altogether the solution will become y by tangent, so y by x. Okay, it's tangent y, come on, sometimes it occurs to me. Tangent y by x, that is equal to x cube minus 1, right? It might be expressed explicitly, y is equal to x into tangent inverse x cube minus 1. That's the explicit solution. I hope you will be okay with these solutions, and you will be okay with the separable equations and a reduction to separable equation. We have done quite a few examples and practice questions as well. If you are okay with it, you don't need to go to the end of the video. So thank you very much, and I hope that you will subscribe the channel to get notification for other videos. In the next lecture, I'll be talking about exact equation. Thank you very much for watching this video.